All right, welcome everyone. In this study guide, we're going to roll up our sleeves and tackle a complete case study. We'll take a simple set of business rules and transform them step by step into a really powerful database schema. So here's the game plan. First, we'll lay the foundation with the core building blocks. Then we'll see how to connect all the pieces. After that, we dive into the classic, and sometimes tricky, many-to-many puzzle. We'll also look at a few special cases you'll definitely run into. And finally, the grand finale, turning our blueprint into an actual database. Ready? Let's jump in. Okay, every single database project begins right here, with a simple goal. In our case, the company needs to keep track of its employees, its departments, and the projects they're working on. Right away, those three things, employees, departments, projects, should be jumping out at you. These are our main entities, the absolute core nouns that our whole system is going to be built on. All right, let's get into section 1, the core building blocks. We're talking about entities and attributes. You can think of this as, gathering up all our Lego bricks before we start building. We've got to know what pieces we have to work with. So first things first, what is an entity? Well, it's pretty much any real-world thing, a person, a place, an object, even a concept that we need to store information about. So based on what we just heard, what are our entities? You got it. Employee, department, and project. It really is that simple to start. And here's what that looks like in practice. We literally just take those nouns, employees, departments, and projects, and draw them as simple boxes. This is the very first, most fundamental step in creating what's called an entity relationship diagram, or ERD. This diagram is going to be our blueprint for everything. But, just having a box that says employee isn't very useful, right? We need to know things about the employee. What's their name, their social security number, their address, all those little details. Those are called attributes. Now, attributes come in a few different flavors, and it's super important to know the difference. You've got your simple ones, like gender. Then there are composite attributes, like a name, which you might want to break down into first and last. Super useful. Then you have multi-valued attributes, for when a department can have, say, multiple locations. But listen up. The most important one here is the key attribute. This is the big one. It's a unique identifier, like an SSN. It guarantees that we can find exactly one employee and never, ever mix up their records. Seriously, getting your keys right is absolutely critical. And here you can see how this all comes together on the diagram for our department entity. See how name and number are just ovals? But look closer. The number is underlined. That tells us it's the key. And locations has a double oval. That's the visual cue that it's a multi-valued attribute. Learning to read these little symbols is what makes an ERD so powerful. Okay, time for section 2, connecting the pieces. Right now, we've got these entities, but they're basically just separate islands of information. They don't have anything to do with each other yet. So now we need to build the bridges, and we do that with relationships. This, my friends, is the R in ERD. And this is where the magic really happens. We look back at our requirements and we find a rule. The rule says an employee manages a department. Boom. We take that English sentence and translate it directly into our diagram. We draw a line connecting employee and department and put a diamond in the middle, labeled manages. We've just turned a business rule into a structural fact. Now, you're going to see these little numbers on the lines, like 1 and N. This is called cardinality, and trust me, it's a huge deal. It's how we enforce the rules. For example, a 1-to-1 relationship means one employee manages exactly one department, can't manage two. A 1-to-N or 1-to-many relationship means one department can control lots of different projects. These numbers are like the grammar of our database, and they stop us from putting in garbage data. So let's add another one. The business rule says departments control projects. So we add the controls relationship. And see, we put a 1 next to department and an N, which just means many, next to projects. Our diagram now visually screams the rule. One department can control many projects. It's becoming a real blueprint. All right, section 3. Now we get to a really common scenario, but one that can be kind of tricky. This is the famous many-to-many puzzle. And honestly, this is a concept that trips up a lot of people when they're starting out. So let's break it down. So here's the puzzle. An employee can work on many different projects at the same time, right? And any given project will have many employees working on it. See the problem? It's a many-to-many situation. We can't just draw one line between them. That doesn't work. So how in the world do we model this? The solution is actually really clever and elegant. What we do is create a new entity that sits right in the middle. We'll call it works on. This new table breaks that messy many-to-many relationship into two clean one-to-many relationships. And here's the best part. This new works on entity is the perfect place to store information about the relationship, like how many hours did this specific employee work on that specific project. It's the only way to do it right and avoid total chaos. Okay, moving on to section 4, handling special cases. Because let's be real, the real world is messy, and sometimes you run into situations that need special tools. Let's look at a couple of those. First up, what happens when an entity needs to have a relationship with itself? Sounds weird, I know, but think about it. An employee can supervise another employee. This is called a recursive relationship. We model it with a loop, like you see here. It's the perfect way to build things like an entire company org chart right into our database structure. Next, we have something called a weak entity. A weak entity is basically an entity that can't exist on its own. It's dependent on another one. Think about an employee's dependence for insurance. A dependence record only makes sense if you know which employee they belong to, right? Their very existence in the database is tied to that employee. This is super important for stuff like tracking benefits. And now for the grand finale, section 5, from blueprint to database. We've done all this careful planning with our ERD. Now it's time to turn that drawing into the actual physical tables that will make up our database. This is where the rubber meets the road. Step 1 is the easy part. Every strong entity we drew, employee, department, project, becomes its own table. Simple as that. The attributes we listed, those become the columns in the table. And that special key attribute we underlined, like the SSN, that becomes what's called the primary key for the table. It's the main identifier. Okay, step 2, how do we create those relationships? For a one-to-one relationship like manages, we use something called a foreign key. Check this out. We take the primary key from the employee table, the SSN, and we add it as a new column over in the department table. We'll call it MGR_SSN. That column now acts like a pointer, linking a department directly back to its one specific manager in the employee table. And now for step 3, the big one, solving that many-to-many puzzle. Remember our clever works on linking table? Well, it gets to become its very own table in the database. Its primary key is made up of 2 foreign keys, one pointing to the employee's SSN and one pointing to the project's number. This table is literally a bridge, and it's the perfect home for that hours attribute we wanted to track. Last but not least, step 4. What about that multi-valued attribute, the department locations? We use the same trick. It also gets its own table. We'll create a new table called dept_locations. It has a column for the department number, a foreign key, and a column for the location itself. This lets us list as many locations as we want for any department, and it keeps our main department table clean and organized. And that's it. We've gone all the way from a few sentences on a piece of paper to a complete, logical, and powerful database schema. Following this process is literally what separates a functional database from just a chaotic mess of data. So I'll leave you with a final thought to chew on. Looking back at everything we did, what do you think was the single most critical decision we made today to prevent that chaos? Think about it.